All right, welcome to day 2 of the reInvents. For some of you, this might be a last session. We'll make sure this is a fantastic session for you. Welcome to SVS319, Unlock the Power of Generative AI with AWS Serverless. This is a jam-packed agenda, so I'm going to start with my introduction. My name is Uma Ramadas. I'm a Principal Specialist Solutions Architect on Serverless. I have here Patrick.
Hi, I'm Patrick O'Connor. I am a prototyping engineer in AWS, and I'm actually going to be presenting with a customer of mine.
Thank you, Patrick. I'm Martin O'Gorman. I'm the head of data science at Parameta based in London.
Hi, everyone. My name is Duraj Mahapatra, and I'm a principal specialist SA focusing on Bedrock and serverless. Happy to be here. Thank you, Uma, Patrick, and Martin for the introduction. And thank you for being here. I know you have been attending a lot of sessions, and you are interested to be here to learn about serverless and generative AI. So real quick, we have a lot of good content to cover, and we'll go through them, and you'll see how we want to build a story around what we are going to talk about. So what we're going to cover today is how we're building applications using generative AI models. We'll look at some use cases and patterns for model inferencing. And as Martin mentioned, we have Martin as a customer. He'll talk about his journey with serverless and generative AI at Parameta Solutions. And finally, we'll wrap it up with a lot of resources for you, where you can go and play with whatever we talked about and see how serverless plays really well with generative AI. Along the same lines, what we're not going to cover is basics of foundation model, or how to pre-train or fine-tune foundation models, and model evaluation strategy. You will find different other sessions which will cover around these topics. But before we jump into any kind of use case or pattern, let's go and look how the generative AI stack looks like today on AWS. So on the bottom, you have the infrastructure for foundation model training and inferencing. You'll see a lot of GPUs, Trainium, Inferencia chips, Nitro system, AWS Neuron. All of these are the foundation of how we bring those infrastructure to run, train, and inference foundation models. Right on top of that, we have Amazon Bedrock as a serverless service that provides you a lot of capabilities around those foundation models. Like, it also gives you agents, it gives you some guardrails to build applications around Bedrock. You have Bedrock Studio, where you can play around large language models and see how and what fits better. You can also custom import your model and make them work on Bedrock. On top of Bedrock, you have the highest abstraction layer of Amazon Q. That's where you'll see Amazon Q for Business, Q Developer for Code Gen, so on and so forth, with QuickSight and Connect. But what we are going to focus in this 1 hour is actually how can we use serverless for inferencing in those two stacks, where we have infrastructure and we have with Bedrock. So quite simply put, if you want to access any of the foundation model or Gen AI in general, you need some level of interfacing with this. So in AWS, if you want to build a serverless way of interfacing it, you will need an API. And for that, we have services like Amazon API Gateway for REST services and AWS AppSync for GraphQL interface. Both of them are managed service and serverless in nature, so you don't have to maintain the underlying infrastructure, how to provision API Gateway or how to provision GraphQL. You get a highly scalable services to work with your systems. So overall, it reduces the headache on building boilerplate stuff for you so that you can focus on actually creating API Gateway endpoints and make it work with foundation models. Moreover, you have highly available services because they are spanned across different AZs, and it has built-in security. And on top of that, you pay per use. You don't have to pay if there are no requests coming in to your API Gateway or AppSync. So that's a key part of what we are going to talk about going forward. So keep in mind, serverless APIs on AWS is number one. Then we'll talk about some serverless integrations on AWS. If you think about it, the most easiest serverless integration will be an API gateway with a Lambda function, right? So that is the basis of building a microservice on a full serverless stack. On top of that, we have seen patterns like this, where Lambda functions will be polling from SQS and doing something else. You'll have event bridge pushing messages or pushing events to targets like step functions, or you'll have step functions waiting for a human intervention to happen before it moves to the next state to do some work. We'll see all of them in some fashion in whatever patterns we're going to talk about today. From a Gen AI world, you'll see patterns like this, where Lambda functions are actually invoking foundation model. You'll have step functions doing the same thing natively, invoking Bedrock foundation models. And whichever foundation model you use or large language model you use, responses will be streamed back to the type of compute that you have used. In this case, it can be a Lambda function. So why are we talking about integrations and API? The overall picture is to show you this. You can combine the speed of serverless and the power of generative AI to get the results like rapidly delivering your applications and go to market faster. So the service icons that are mentioned in the bottom, you have these series of serverless services, and with Bedrock or SageMaker, you can do or build a lot of applications. You can proof a lot of applications with generative AI, and you can get to the market faster. So that's the idea of this session, and that's the goal of getting you this idea so that you can take over and work on it. So naturally speaking, what we see from customers around generative AI applications, when they talk to us around these three pillars when it comes to generative AI. First, how can they enhance their customers' experience? How can they boost employee productivity and creativity? And how can they optimize their existing business processes? You will see some of those use cases here. But as part of this session, we are going to cover these broad 5 use cases. And we'll see how that can be also applied to different use cases. I'm pretty sure you'll be able to see the applicability of these patterns everywhere where you can think about generative AI can help. So let's start with the simplest one, with chatbots. I'm pretty sure if you want to play with generative AI today, the first thing you might have done is gone to a browser or something to chat with the language model or the foundation model. So let's focus on that. If you want to build a chatbot today on AWS that provides you generative AI or foundation model capability, you build something like this. You have users talking to the API options that we talked about with API Gateway and AppSync, which talks to a Lambda function, and eventually that Lambda function is able to create a prompt that the foundation model can understand, and you invoke that foundation model to get a response back. This is quite simple. You can do this with Amazon Bedrock, you can use SageMaker Jumpstart, so on and so forth. What you get out of putting API Gateway and Lambda function is the capability to authenticate requests, the capability to rate limit, to figure out a usage plan. All those capabilities are provided by API Gateway and AppSync. That is the first step to figure out or know how you can build API for enterprises that can use foundation models. However, it is okay for POCs. What happens if the number of users go up? You will eventually see this problem hitting the API layer, and eventually, if you don't have a rate limiting, it'll hit the Lambda with number of concurrency that you have to handle, and eventually it'll also hit the foundation model where it'll behave not the way you wanted it to be. You can put rate limiting in API Gateway, but at the end of the day, you don't want that user experience to be bad. You want all of your user requests to be handled really well and not deny those requests or send a throttling output saying that we can't handle your request. So for that, you shift your mindset from synchronous way of handling things and go to a more asynchronous way of doing things with control flow. Let's see how that happens. Same scenario, you have users calling API Gateway. Instead of directly calling a Lambda function, now you collect all those incoming requests inside an SQS queue. And SQS queue acts as the buffer right now. Now think about the slide where we have serverless integration. The first one was Lambda polling from SQS queue. So now when the rate of request goes up, you have a buffer instead of overwhelming the Lambda function or the downstream foundation model. Lambda can pull from the queue and eventually send that request to Bedrock, for example. And once the response is received, now that we have broken the synchronicity of the entire setup, there should be a way to send the response back to the client. And it has to be done via something like API Gateway WebSockets or IoT Core or any other mechanism that can asynchronously send responses back to the client. What you gain out of this is a decoupled architecture, which is highly scalable. You have a lot of good attributes that you can put on SQS and Lambda event source mapping to define how Lambda should scale, and we'll touch on that later on. So overall, you get a setup for a chatbot that can handle scale or handle the number of requests coming in. So with that thought, let's see how we can make this kind of chatbot or large language models work with your organizational data. It is good to have chatbots giving static response, but enterprise-wide in production, you want this kind of capability to work with your data. For that, I invite Uma, and she'll dive deeper.
Your data is what sets you apart. So you need to have your data accessible in the right place and in the right format. So the key to do that is to build an end-to-end data strategy with a good, strong data foundation. AWS offers a broad array of services that you can use to build your data foundation. I have highlighted here a few services that you should have in your toolkit every time you're integrating with data. Once you have your data in the data foundation, you can make it accessible to others. You can put guardrails on it. You can use it for advanced generative AI techniques, such as continued pre-training, fine-tuning, and retrieval augmented generation, or RAG. Now, coming back to this question, how do you make the large language model work with your data? All of these techniques are efficient to get the large language model context-aware. But RAG is particularly powerful and cost-effective, and so we are going to use that as an example to showcase the benefit of implementing it in serverless. Just a quick refresher on RAG. When you have a question that you want to ask generative AI, instead of asking that question to the large language model, you dip that question into a knowledge base. You get the relevant information for that question, you augment that question, then you ask the large language model. Now, with additional details that is given in the input, large language model is able to give you more accurate response. For this RAG process to work, this knowledge base is really important because that is where your input data is stored in certain format called vector. And you need a special kind of a model called embedding model to generate that vector data. So the whole process of generating the vector data and hydrating this knowledge base, that's not an easy process to do. And so if you are using Amazon Bedrock, Bedrock knowledge bases is the fastest way to get started with RAG, because it offers you several different data sources that you can tap into, get your data, apply different kinds of chunking strategies, create embeddings, and store that vector data into several different vector databases. But sometimes you want to have more control and flexibility into how you build and manage these knowledge bases. Or Bedrock is not an option for you. So for those of you, we have taken this hydrating the knowledge base as an example of document processing. And we chose this example not just because RAG is popular, but also because it is best done in serverless. Why do I say that? When you can run Llama Index or LangChain in Lambda or ECS and get this process done. Document processing is generally unstructured data processing. Think of audio-video recordings, email conversations, chat messages, or even social media feeds. Some of these data need to be classified, transformed. Some needs to be checked for sensitive information. Some of them need to be masked, and data quality needs to be checked before you can do with embedding or storing that data. And so That tells you that it requires precise orchestration, making a service like Step Functions ideal for this use case. Additionally, you're not processing for like few documents, you're processing the steps for like tens of thousands of documents. And so as a developer, I might think, I may just iterate on the collection of documents that I have and use a for loop or maybe an iterator library. But the challenge comes in when we are scaling. How do we effectively, efficiently process tens of thousands of documents? Are we going to vertically scale? Then how much CPU or memory are we going to allocate? Are we going to add more threads? How many threads are we going to do? If a process fails in the middle, are we going to restart from the beginning all the 10,000 documents? So that's where Step Functions distributed map comes in. In my mind, distributed map is a game changer in processing large-scale data, just like the RAG use case. If you're not familiar with distributed map, it is a state in Step Function that allows you to iterate on collection of objects in S3. You don't have to specify how many iterations you need. All you have to do is to point that state to where your locations of objects are, and then specify what you want to iterate. Once you do that, it automatically figures out. It gives you a lot more control to process large-scale data. For example, you can set how many iterations you want to run in parallel. 1, 10, 40, thousands, you can do that. Why is it important? You don't want to send too many invocations to your large language model. You don't want to inundate them. You can also batch documents. Instead of sending 1 document per iteration, you can send 10 documents per iterations. More importantly, you can redrive from the point of failure. Meaning, when your process fails, when you're processing 10,000 documents, you don't have to restart from the beginning. You can restart from the failed documents. And above all, you get complete visibility into how many iterations are there, which means how many documents are you processing, and which iteration it is, how many iterations were successful, and what is the input, what is the output, and everything comes right there for you. And so when you build your RAG pipeline with Step Functions and all the services that I have here, you are truly building a better together story. You're running your LangChain or Llama index library in Lambda or ECS for transformation or for chunking large documents. You're using Bedrock embedding model to create the embeddings, store the embeddings in OpenSearch Serverless, and schedule the entire pipeline using Amazon EventBridge Scheduler. All of these services here are serverless, purpose-built, and they work really well together. And so what we just saw is how distributed map, a purpose-built iterator, can simplify processing large-scale data. Redrive from the point of failure is a lifesaver because data can be messy and unpredictable, and especially when you're dealing with large data. Whether you're processing 10 documents or 10,000 documents, serverless handles that variability really, really well. And so that you can focus on what matters to you the most, which is delivering the business value. So what we just saw is how you can implement a large-scale data processing use case, such as like RAG in serverless. So RAG, or the hydrating this knowledge base use case, takes you one step closer to get the large language model to be aware of your input data. Let's see how it fits into the overall API question Dheeraj asked.
Thank you, Uma. So let's get back and summarize what we learned and how we can use. So the top section is what Uma just talked about, how to actually create vector embeddings using Step Functions. The bottom portion is what I mentioned about chatbots, how do you do asynchronous. But now the question is how we can implement both of them together so that you can use your organizational data. Everything stays the same almost in the chatbot scenario, but the new thing that gets added is now the Lambda function has to actually refer to those vector embeddings or get vectors, use vectors to get a similarity search. And that similarity search will provide some relevant context to that Lambda function. And now with that additional context and the question that was asked earlier, Lambda can actually call the large language model. And the large language model will send a response back. So you can imagine that with that additional context, the rate of hallucination goes down and you will get more deterministic and very focused information back from the large language model. And once the answer is returned from the model, the response will be the same way that we discussed earlier. So this entire process is what we call retrieval augmented generation, where we talked about creating vector embeddings and then how we use that in our application. So this is all good. We are now dealing with static data, and large language models are returning responses based on our organizational data. Can we check whether that's the horizon or can we go beyond that? Can large language model take actions on my behalf, right? So that's where use cases like virtual assistants come into picture. Let's see how we can correlate that to one of the older use cases we have seen, or everybody must be here like dealt with it at one point, is how you interacted with booking agents before actually internet was there and we had at our fingertips all the capability to book a reservation. This is how the interaction would have gone if you were to book a flight or a hotel or a rental car. The first thing that as a user you would ask is, I'm traveling to so-and-so place, in this case it's Orlando, I need flight, hotel, and rental car. That will have follow-up questions from the agents like this. What is the departure airport? What date are you departing? And that conversation will keep on going until the booking agent has all the information in place to actually successfully book a reservation. Now take that analogy in mind and see how we can get that done with large language models. Can large language models act like this booking agent who was working on our behalf? So let's see how it looks like. The same thing, we have the serverless application. As we talked about earlier, we have the large language model on the right, and users are asking questions like, book a reservation for my trip to Disney World as a travel agent. Right away, if you ask a question like this, the LLM will send back a response saying that I'm not capable of doing that because I cannot take actions right away for you. And that is where we have capabilities like agents. You must have heard about LangChain agents, Bedrock agents. Those agents will be working alongside with large language models to orchestrate the work and figure out how we can get this booking of reservation done. Same approach with agents. It can invoke an API call or do some search, call a knowledge base, and its goal will be to actually book that reservation for you. So Bedrock agent is one of the way you can do this. What we are going to focus on today is another way to get this done, where you don't involve an agent orchestrator like Bedrock agent, but you try to do that using the capabilities of serverless and step functions that we have showcased. So the same question, in this case, when the question is asked, like to book a reservation, the serverless application will send this system prompt saying that you are an AI agent or to AI travel assistant, and you have to book some reservations, and these are the tools at your disposal that you can use. This capability is called function calling or tool use. So the difference between this and the previous slide is that agent was orchestrating on your behalf, but in this case, the large language model will just give you hints as which tool to invoke, and it becomes your responsibility to actually invoke that tool. When I say your, I'm talking about the serverless application. So in this case, if you say that we have get owner info as a tool, get passenger as a tool, get reservation as a tool, and we ask large language model, hey, this is our initial request, tell me which tool should I use? And the large language model will use NLP and figure out which tool to use, and it'll just let you know that, hey, for me to go forward, you have to use get owner info. You have to invoke get owner information. And that's when the serverless application will invoke either an API or a Lambda function, get the response back, and feed that response back to the large language model to figure out what should be the next tool. So this is how it will look like as a conversation. But before we jump into the conversation, let's see how you define a tool. With a system prompt, as I mentioned earlier, the model ID that we used in this example will be Sonnet Claude 3. And you define tools like this. You have get owners info. You describe what get owners info does, and you provide a schema. And then you have get passenger information that describes what it does as a tool. You provide a schema. The same with booking reservation. In this example, we just used 3 Lambda functions as those tools that sends back those business logic. If you send a owner ID, it will get owner information. If you send the owner ID again, it will give back passengers. And then finally, you send a JSON to book a reservation. So let's see how it looks like inside a step function. So we have already built this. The sample is available. It's all available for you to play around. It will be available in the resources section. So this is the entire step function that can do this virtual assistant scenario for booking agents. Let's go step by step. The initial question that will be asked is, Mr. John Doe with this owner ID is planning for a surprise trip. Okay, and we have to plan this trip within 5 hours. So the step function takes that request and gets to the Bedrock model here, which is mentioned in blue color. And then the Bedrock model decides, okay, for me to go forward, you have to use this tool. What is this tool? It's get owner info. And it also parses the owner ID from the input text, and as you have defined in the schema. So it tells you which tool to use, and it tells you what should be the input for that tool. And it says the stop reason is tool use. You have to use a tool and get back to me so that I can tell you what to do next. Okay? And the output token in this case is relatively lower than the input token that was passed in. So keep that in mind, how it will be useful, where you don't have to send a lot of context back. You just send enough context to move next to get a reservation booked. So what happens after that? Now the conversation actually starts. This is how the user asks the question. Then the assistant, in this case a model, replied you back with this statement saying that you have to use this tool. And then you, as the serverless application developer or user, provided this result as a JSON string saying that this is my tool result. All of those information are fed back to the model saying that this is my new context with all the information. Tell me what next. Next, the large language model comes back and says, okay, we have owner information right now. Now I need passengers. So go and get passengers. Use that tool. This is the owner ID. Go get the passengers, and then we'll move next. Once passenger is received, we have all the passenger information. Finally, the step function or the Bedrock model has everything to book a reservation. Now it will say, I have everything. This is my input payload for booking a reservation. If you check here, it has owner ID, first name, last name, departure airport, arrival airport, all the passengers, so on and so forth. So it's good to book a reservation now. Now this schema is already defined, and you just feed that into the book reservation API or Lambda function that will book the reservation for you. So you can see the recursive nature of this happening until Bedrock model says that I don't have any more tools to use, so the stop reason is end turn. Now I can bail out from the step function saying that, okay, I'm all done, my reservation is booked, this is my summary, so we are all good. If you need additional information, we'll send it back. So these responses are provided by the large language model. So what are the benefits in this scenario? So since the token size are smaller, we get deterministic response with tool use. You can execute existing business logic. Let's say in your enterprise, you have already defined how those 3 tools should behave as APIs. You can just plug them in as tool and make them work. And then you can do better error handling because step functions provides you that capability out of the box. Natively, you can handle that. You can improve the performance because now you are not getting thousands and thousands of tokens back for each LLM call. You're getting drastically lower number of output tokens, like just the tools to use, and then you can work on that to get this virtual assistance thing done. That's all good. Let's jump into this scenario of how large language models now can assist in going through a large set of documents. So for that, I'll invite Uma back again.
This use case does not need any introduction. Generative AI is a game changer in creating concise summaries from lengthy conversations, extracting key insights from product reviews, and simplifying large documents like mortgage documents. And so the application of generative AI in document summarization is virtually limitless. So in this part of the session, I'm going to talk about a couple of ways you can implement summarization and a cost-effective way to implement batch summarization. There are times you want to create summaries on the fly, real time. So you can enable your users to upload their documents, perhaps through API gateway to S3. Then you can leverage S3 event notifications. S3 send event notifications on file uploads to multiple destinations. One of those destinations is SQS. Then you process the messages from SQS in Lambda and run the summarization. You might use some purpose-built libraries that are purpose-built for transformation, for chunking large document, etc. Why did I use SQS here? Why did I not send the event notification directly to Lambda? Because Lambda is also a supported event destination. When you have multiple users uploading documents like this, you will see bursts of events going from S3. Lambda can handle the surge, but it can quickly overwhelm the AAML services. That's why we are introducing an intermediary between S3 and Lambda so that we can control the flow of messages from S3 to AAML services. Dheeraj earlier talked about this pattern, asynchronous pattern. So when you process messages in Lambda from SQS, there is this setting called max concurrency. When you set the max concurrency, Lambda makes sure it only spins up that set number of execution environments to process messages from SQS. In that way, you're processing messages reliably, in this case, summarizing documents reliably, even though the services that it is connecting to are scaling at different limits. There are sometimes you want to process documents in batches. You have bulk documents, and you don't want to run them event-driven. So the best way to run them is on schedule. You can use Amazon EventBridge Scheduler to schedule. And we saw earlier in hydrating knowledge base use case, when you have large number of documents, you can use Step Functions distributed map. So again, in this use case also, you can use the Step Functions distributed map, point to the location of documents, it will iterate automatically and summarize for you. And we earlier, in the previous slide, we talked about concurrency. Similarly, in distributed map, you can set the concurrency so that your AAML services are not overwhelmed with too many invokes. Because this is a batch summarization process, you need to store the summary somewhere. You would choose a database like Amazon DynamoDB. When you're running your own model, you're not using some model providers, but you're running your own custom model in EKS or maybe in SageMaker, and you're using it for batch summarization, you really don't want the model to be running 24/7. It's not cost effective. So how do we make it cost efficient? Let's say your model is deployed in SageMaker, and you're using it for batch summarization and using Step Functions for building that summarization. All you have to do is to add a couple of steps, a pre-processing and a post-processing. In the pre-processing, you make sure the SageMaker model endpoint comes up alive. You will wait until that endpoint comes live. Step Functions invokes SageMaker API directly. You really don't need any compute in between. It can invoke the API. It can also wait. And so you do that pre-processing, making sure the model endpoint comes up live. Then you do the batch summarization. After the summarization is done, in the post-processing, you will delete the endpoint. So by making sure this endpoint is handled ephemerally, you are saving cost. You are running your model only when you need it. If you're using Bedrock, there is a batch inference API. This allows you to send a bunch of prompts in as batches. So that's another way to save cost if you are summarizing batches. I think we have a fair idea about how you can implement summarization using serverless. Now we're switching gears and going to look into another exciting use case. It's content creation. In this part of the session, we'll look into a couple of techniques, prompt chaining and human in the loop, how they improve the overall accuracy and performance of generative AI application, and how you can implement them. Prompt chaining is one of the great ways you can improve the model accuracy and performance. Take, for example, writing a blog, a technical blog using generative AI. A typical blog consists of multiple sections: overview, problem statement, solution, etc. Is it a good idea to generate the entire blog using a single prompt? Probably not, because you will end up with too many edits that you would have written the blog yourself. An all-encompassing prompt additionally have other downsides. When you're making changes on one side of the prompt, other part of the prompt may get impacted. You might need a more sophisticated, large model, so it can be expensive and also slower. Overall, maintaining, tuning, testing a large prompt is really, really hard. So just like programming, you should think about single-purpose prompts that are clear and focused. And so the way to go about doing that is to decompose your large prompt into smaller prompts and wire them up in such a way that makes sense for your use case. And that technique is called prompt chaining. Fantastic way to run prompt chaining is to use step function. Why do I say that? When you have multiple prompts, because you're chaining prompts, you have multiple prompts, you might have to wire them up sequentially, parallelly, and iteratively. Step function offers you all of those different flows that you can easily use to build that prompt chaining. Because now you have purpose-built prompt, you can also use purpose-built models. For example, to generate code for your blog, you can use a model that is trained with code generation. Because you're using purpose-built models, your model could be inside AWS, outside AWS. Maybe it could be a private API. You can use HTTP API integration of step functions to connect or invoke your model directly. You really don't need any additional compute. You are invoking directly from step functions, which means you're simplifying your architecture. Above all, you get complete visibility into all your prompts, how they are wired together, how they are executed, and where you need to make changes to make your blog better, right? The prompt optimization is another advantage of using step functions because of the observability. There is also another technique that improves the accuracy of your generative AI application. That's including a human reviewer. Of course, we want to automate everything. That's why we're using generative AI. But there are use cases where safety and accuracy of your application that you show, the response that you show to your customers is more critical. And so you will have automated evaluation, and if those evaluations fail, you might have a human reviewer. Implementing a human reviewer with step functions is really one of the common patterns. The way you do that is when there is a step you need to connect with a human reviewer, you use a pattern called callback pattern. When you use that, it generates a token, and that token is sent to an integrated services and then to the reviewer. And the step goes to a pause state and will wait until the token is returned to it. Now the human reviewer reviews it, and they either approve or deny, and they will send the token back with their response. When they do that, the step will receive the token, goes to the downstream services based on the response the human reviewer sent. As you can see, this is really, really simple to integrate a human reviewer process with step function without you having to manage state, dependencies, or even the token. And so what we saw just now is you are going to use more and more purpose-built model because you want to improve the accuracy and performance of your generative AI application, and you will be switching models for the time being. Serverless allows you to plug and play models easily. We saw how step function allowed you or lets you easily integrate a human in the loop and implement prompt chaining. And then last, we saw how the observability along with prompt chaining gives you better control into optimize your prompt. Now, what we saw so far is how customers are building generative AI applications using serverless. Now, we are going to hear directly from Martin on how they are using serverless for their generative AI journey.
Awesome, thank you. So we're going to take a bit of a shift now and actually bring a customer that has been using a lot of these features in a prototype. But before we go there, I'll give you a bit of context. I'm Patrick O'Connor. I'm a prototyping engineer here at AWS. It is my job to work in a very rapid 4 to 6 week style with customers directly on innovating, particularly on new technologies like generative AI. So before we go into the prototype, I want to introduce all the way from London my customer, Martin, who's going to give you a bit of context on what the problem was.
Thank you, Patrick. So as Patrick said, my name is Martin O'Gorman. I'm the head of data science at Parameta Solutions. And as a bit of background, Parameta is the data division of TP ICAP Group. Now, TP ICAP Group is the world's largest interdealer broker. It brings together institutional buyers and sellers across all the major financial, energy, and commodity markets. In doing so, it facilitates trillions of dollars of trades per year, and this generates millions of financial data points every day. Now, at Parameta, we make this data accessible to our clients through innovative data products and data distribution solutions. So our Gen AI journey began 18 months ago, where we had an immersion day at AWS. Now, we brought some ideas to the table, problems that might be amenable to Gen AI, and we decided to pick one to move forward with. Now, this initiated a prototyping engagement of which Patrick here was one of the engineers. And as a result of this prototyping engagement, we worked closely with these guys for 4 weeks, and we ended up with a working prototype. Now, in the meantime, over the last 18 months, since then, we've worked on many different use cases across all the categories that the guys have been talking about so far in the presentation. Now I'd like just to focus on this regulatory assessment use case. So when it comes to regulations, we have a product team that builds benchmarks and indices. Now, when it comes to benchmarks, there's 2 types of documents at play. One is a regulation, which is a set of a legal document that stipulates what can and cannot take place in financial markets. On the other hand, you have a methodology document. This is public-facing, and it describes how a regulation is created, what currencies are involved, and any other defining parameters. Now, when it comes to methodologies, it's important to note here that a methodology must cover each and every regulatory rule, and there are many of these. So the object of the prototype was to use Gen AI to automate this process and while maintaining accuracy. Now, Patrick is going to talk through the actual architecture.
Awesome, cool. So now that we understand the problem set being that we have this regulation that's stipulated by a governing body. And we have this methodology which is created by companies to interpret and understand what is stipulated in regulation. The prototype focused on both these documents, which you can see from the architecture at the start here, is we ingest regulation, and then we need to digitize each of these rules that we must abide by. But then we also have this other document, methodology, in that we then have to cross-reference the methodology to the regulations. So the first thing we did is we leveraged a service called Amplify. This is a suite of services on AWS where you can come in and you can host the front end. So we built a React TypeScript front end with the focus of allowing Parameta solutions to come in and simply upload both these regulations. We then used Okta IDP, which you can see down the bottom there, which is the choice to natively integrate into Amplify so that we can securely authenticate anyone logging onto the site, but also leverage AWS AppSync. We traverse AWS AppSync, which is our backend API system, to securely connect to a serverless backend. So in this case, when the user submits a regulation or uploads a regulation or methodology, we then upload it into an input bucket or an input S3 bucket, where we then trigger this step function. Now, the step function is really where the magic happens. The first process of the step function is to differentiate between a regulation and a methodology. In regulation, what we do is we need to parse out each of those individual rules that you saw before. So for example, in the Great Britain market, there are rules that are governed, such as you must trade in pound, or you must abide by certain markets within different regions. We pull out these rules, and then we store them. For methodology, this is a different process because the whole document is scanned against these regulations. We'll have a deeper dive, but then the last thing we do is once we've parsed out this information, we then do a series of Gen AI activities. So you can see on the screen there that we do summarization. We use Bedrock to do summarization. We did an initial experiment with keyword searching, so using keywords in the methodology to see if it complies with regulation. And then the final one there, which is really where the magic happens, is we then use large language models on Bedrock to be able to scan the whole document and label out what's in breach, why it's in breach, and what are some suggestions that you can offer to help improve those breaches. And then once we save those results, we then put it into a NoSQL database known as Amazon DynamoDB. And then the last feature there, which is something I like to highlight with this prototype, is that this chatbot at the end, so for context, this was the first Gen AI project that we did last year, the prototyping team, in August. The customer was so invigorated that they went one step further and introduced their own chatbot using Bedrock. Now let's have a deeper look on what's actually happening in that step function. So you can see from the screen here that it's quite a complex array of different iteratives, different actions that were previously mentioned in the slide here. So let's have a look at the first item of decision that we're using here. And that's a decision tree up the top there. So within this step function, we're handling regulations and methodologies, and we're using the inbuilt mechanism to be able to choose the relevant path of whether it's regulation or methodology. We're then using other features such as iterative patterns. So you can see this iterative pattern on the right side. What this is doing is we have the regulation saved rule by rule. We're looping within the step function rule by rule. So we're taking the first rule, which might be, we're in Great Britain, has to be pounds. And then we're taking that rule and we're going over the document and saying, does this document comply with this rule? Using context, the LLM will then scan it, find areas where maybe there's a euro introduced, or maybe there's contextual explanation of a non-Great Britain currency being mentioned. It will then pull it out, save it into tabular form of what the breach is and explain why. And then we use that iterative pattern to go into all of the rules. Another feature we're then using here is then the Bedrock call, or the AI call to the large language model. Completely serverless, because what we're doing is in the relevant sections, we're having a Lambda do that prompt chaining or that prompt curation so that we can relevantly summarize on the very left there. We can do another summarization, but more importantly on the very right, you can see the compliance check, all leveraging Bedrock. And then in relevant parts, we then have that error handling. Should the LLM hallucinate, or if there's other aspects that aren't captured, we can capture that error and notify via the front end or the back end system of what has gone wrong. And then the final callouts here are Lambda tasks. All of these work in orchestration to be able to create this completely serverless workflow that allows us to parse and detect compliance breaches. So on this slide, I want to bring you back on, Martin, and I want to ask you, what are some of the other projects that you've done since that prototype?
Yeah, thanks, Pat. So I think what I want to focus on here is just how the team has adopted serverless technology to build out applications. So here we see a workflow that automates the triage of client support tickets. So typically, what we're beginning to see are design patterns at a macro level that can be leveraged across different generative AI use cases. For example, up front here we have message processing that contains two GenAI components. One is to classify the support tickets, and then depending on the result of the classification, we have entity extraction, where meaningful entities are extracted. So this typically leads to actionable outcomes, often orchestrated with a step function, and containing RAG components. So for example here, we are taking the entities that we've extracted from the entity extraction step, and we're building SQL queries using a text-to-SQL model, and we can use this to query our external data warehouse, in this case Snowflake. We also have a knowledge base that we can use to search for any client information that might be useful in resolving this support ticket. Now, it's important to remember here that support tickets are unstructured. Another pattern that we're finding that we use across all our GenAI models now is model evaluation. So here what you can do is you can build up a test set of data and use it to evaluate any new model and prompt combination and compare it against the current best. So really what we're finding is that serverless and GenAI is driving innovation. It's helping us to automate workflows, and we're finding that we can unlock siloed data stores. This is leading to cleaner data, better data governance, and as a result, we got new revenue streams. Two of the pillars of Parameta's strategy are digital transformation and cost optimization. And so by moving your workflows onto the cloud, it's helping us to achieve these. And generally, we have a much happier, productive data science team because they're using this new technology. And of course, satisfied customers. So I think, Diraj, you're going to wrap up now?
Yep. Thank you, Martin and Patrick. That was a really good end-to-end story when it comes to Parameta solutions. So time to wrap up. Let's revisit what we captured today. We covered the multiple use cases, starting with the simplest one with chatbots, and we saw how we can run them at scale. Then we dove into document processing. We saw how we build retrieval augmented generation, how we create model, and then we use step functions to create those vector embeddings, and then we reconciled those two approaches, how we can have chatbot and RAG specific applications built together. Then we jumped into virtual assistants, where we talked about step functions using tool use or function calling to really book a reservation, which is a very powerful concept if you think about Bedrock agents and likes of that. And then we moved on to document summarization at scale, how you can do document summarization with step functions when Bedrock is not an option, or how you can do with batch processing with Bedrock. That's also a very common industrial use case with different customers. Then we talked about content creation. This is very crucial for marketing teams if you want to create content at a faster pace, also involving human in the loop in the process of approval. We saw that using step functions too. So if you want to summarize, before I summarize that, the last process that we checked with Parameta solutions is how they have optimized the process as well. So we covered a lot of those scenarios. If I want to summarize, this is how it'll look like when we talk about generative AI and serverless working together. You'll be able to build Gen AI applications with serverless faster. Your application will be evolutionary in nature. What does that mean? It means you can plug in new components without breaking the existing ones. So you start building evolutionary architecture when you think about serverless and start with generative AI models. So let's say if there is a new model tomorrow that you want to use that has better accuracy or better score, you can just switch the old one and put the new one, and it should work as expected. You get fine-grained scaling components because you have something like SQS in middle that can buffer, so you can handle the scale when it comes to the Lambda function or the foundation model behind the scenes. So that power you get when you build with small components using serverless architecture. You can easily inference multiple models because it's evolutionary in nature. You can test out new models and see what works for you or your business use case, and then fail fast and then build faster. It offers rich integration. When we talk about step functions, which we did not touch on today, is step functions provides 220 plus API integrations today natively. I can call Bedrock directly without writing a Lambda function from a step function. So there are many other services that you can integrate with that works according to your need or according to your use case. Last but not the least, we want to automate everything, but we also want to have some human approval in the nature of this process, because we know things with large language models are still non-deterministic. So we want a human eye to look at things and approve when you think that the content has to be made public or the content has to be appropriate for the audience that you're focusing on. With that, these are the resources you can get. So if you scan this QR code, I'll halt here for a minute. You'll get the resources around this. You have multiple blogs. We have resources around workshop. I have a sample application that talks about the tool use scenario that we talked about, private aviation booking. So that will be covered as well. And there is a blog that accompanies that sample application. If you're looking for other sessions, these are the other sessions to check out at reInvent. And you can gain more information around serverless real-time API, AI-powered chatbots, tool use and agents, prompt engineering strategies, so on and so forth. Now, if you want to learn more about serverless, you have these mechanisms. If you scan this QR code, you will get to serverless learning. You'll earn badges when it comes to serverless technology, events, and workflows. And basically, when you start learning about serverless and step functions, events, and workflows, it enables you to think in a more managed and serverless way, regardless of whether it's a Gen AI application or a normal application. But with Gen AI, since the area is very fast moving, things are changing faster, you need some kind of mechanism where you can plug and play pretty quickly. And serverless provides you that mechanism. With that, thank you all for attending. This is the team on the stage. Please review our session, provide your feedback. How did we do? We'll be happy to take this feedback, and we'll come back again next year, or whenever we meet, we'll dive deeper on very new topics that are exciting. Thank you all.
Thank you so much.